Welcome to IIT and Gate classes. This is lecture 7 on compiler design. And in this lecture, we are going to start recursive descent parser. Okay. So first of all, let me clear some basics. See, we have already studied top-down parsers are of two types. Okay. One is top-down parser with backtracking. And another is known as top-down parser without backtracking. Okay. So top-down parser without backtracking, that is known as LL1 parser, which we have already studied in the previous lectures. Okay, LL1 parser, and this is also known as non-recursive descent parser. Non-recursive descent parser. Okay, and it is also known as predictive parser. I have already told you all these things. Now, the second category of top-down parser is top-down parser with backtracking. That is known as recursive descent parser. Recursive descent parser. Okay, and in this lecture, we are going to cover this recursive descent parser only. Okay, so as the name suggests, here we have backtracking. Okay, so backtracking is done here. So let me jump to the slide and show you how exactly this parser works. Okay, so let me write a program. Okay, so the very first thing is, which you should remember is, in recursive descent parser, we will write a small program for each non-terminal symbol. Okay, and that program will be a recursive program because we have used the word backtracking, and backtracking is done in recursive programs. So we will do recursive programming. Okay, for each and every non-terminal symbol in the grammar. So in RDP, in recursive descent parser, for each non-terminal in the grammar, for each non-terminal in CFG, we will write a recursive program. Okay, yeah. So let me give you a small idea about how exactly this all is done. Okay, so yeah, so let us suppose we have RDP. I am writing for start symbol S. Okay, so recursive program for start symbol S. So I will say select any production, of S. Okay, you will start from any production of S. See, we can have S goes to say A, B, C, or D, E, F, or G, H, I, and so on. We can have any number of productions from S, and we will randomly start from any production. We need not start from production number 1. We can start from here, we can start from here, and so on. We can start from anywhere. So that's why I have written select any production of S, and let me say that production is S goes to x1, x2, x3 xn. Okay, or you can say xk. Yeah, so directly I'm saying that S is going to k different symbols. Okay, now these symbols can be terminal also, non-terminal also, they can be anything. So x1 can be terminal as well as non-terminal, x2 can be terminal as well as non-terminal, and so on. It can be anything. Now I will apply a loop. I will say for I is equal to 0, and I, or rather we are x1 now, we have written here x1. So I should say for I is equal to 1, I less than equal to k, I plus plus, if x of I is variable, or you can say non-terminal or variable is one and the same thing. If xi is variable, then I will call RDP. Okay, RDP xi, recursive form. Okay, this is a recursive form. RDP xi. This is recursion. Huh? See, we are writing just a small program in C language, and that is also a recursive program. So for and we are starting with start symbol S. Okay, so RDPS, select any production of S. So S can have many productions, and we will start from any of the production. And let us suppose that production is S implies S goes to X1, X2, X3 up to Xk. Now I will apply loop because we have K symbols, so I have to check each and every symbol, and I will apply loop for I is equal to 1 to K I plus plus. Now in the loop, I will check whether this X1, X2, X3 these are variable or terminals. Okay, variable means non-terminals or terminal. What are these? We will check. So if it is a variable, then we will do a recursive call. But if it is a you can say terminal, so that means else. In the else part, we will write if. Okay, if it is a terminal, then we will check it. Okay, if xi double is equal to las, look ahead symbol or look ahead pointer. Look ahead symbol, we can write look ahead symbol. So if xi is equal to look ahead symbol is that symbol on which look ahead pointer is pointing. Okay, so I will come to it after few slides, but let me give you a small idea. Okay, so for example, if I say S goes to A B, okay, so and the string is A B C, so here look ahead pointer is pointing to the first symbol, which we have studied in LL1 parser also. So look ahead pointer is pointing to the first symbol. Now this symbol is known as look ahead symbol, because look ahead pointer is pointing to that symbol. Okay, that's why I'm calling it as look ahead symbol. Okay, now if xi is equal to double is equal to look ahead symbol, then I will increment the look ahead pointer. Okay, so I will say look ahead, okay, or let me write it like this, LAP plus plus look ahead pointer plus plus. You will increment it. Okay, and else if symbols are not matching, then I will say parsing error or backtrack depending upon the situation. Then I will say parsing error or I will say backtrack depending upon the situation. Okay, and I know you won't be able to follow it just now, because there are some key points, okay, which I cannot explain without any question. So let me jump to the question and I will explain properly about how exactly this all is done. So the main crux or the main part of RDP we have already studied. That means this is a program. Okay, let me explain one more time so that you get more clarity. So we are starting with the start symbol S. Okay, RDPS, we are saying RDPS. So select any production of S. S can be having many productions. So I will start from any production, whatever production I want. It need not be first, it need not be second, and so on. It can be any production. And let us suppose that production is S implies X1, X2, X3 up to Xk. Now for I is equal to 1 to K, because there are K symbols, so I is equal to 1 to K. Because there are K symbols, so we will apply loop from 1 to K. Now we will keep one by one, we will keep on checking are these terminals or non-terminals. If these are non-terminals, then we will do a recursive call for that non-terminal. If it is a terminal symbol, then we will check that whether that symbol matches or not. If it is matches, then look ahead pointer will increment, otherwise parsing error will be shown. Yes, please note it down carefully, and I will jump to the next slide and I will give you some example. Okay, yeah, please note it down. Okay, so let us suppose we have a grammar like S goes to A, B, C, D, E, F, G, H, I. A goes to A, B goes to C, D, C goes to E, F, G, H, I, J. Okay, and yeah, so let me take D goes to D, E goes to E, F goes to F, G goes to G, H goes to H, and I goes to I. Okay, yeah, please do not get confused about by writing such a long grammar, what I want to say and so on. Please do not get confused here. Okay, so this is a very simple grammar. Okay, and let me give you a string. For example, the input string is A, B, C, D, I, J. Okay, A, B, C, D, I, J. This is my input string. Now I want to check whether this string is generated by this grammar or not. Okay, and let me tell you one thing. How we can generate it? See, if I apply S goes to ABC, this A will go to AB, then this B will go to CD, and then this capital C can go to EF also, GH or IJ. Yeah, so we can generate very easily. So parser will be like this: S goes to ABC, A goes to AB, B goes to CD, and C goes to IJ. Very simple. I can easily generate it. So grammar is very simple. So please do not get confused by the number of production which it is having. So grammar is very simple, and input string is this. Now I will try to run recursive descent parser and show how a parser will give a message that this string is generated. That means how parser will say yes, or how parser will say that string is generated by this grammar. Okay, so let me give you a small idea. So as in earlier, I will apply just this, you can say, program. Okay, I will run this program on this grammar. That's it. So how I will do? Okay, so let me show you properly. Yeah, so here only I will try to show you. Okay, so let me draw a line here. Yeah, so I will say RDPS. See the previous slide, RDPS, starting from start symbol. Na? So we can start from any production rule. So let me start with this only. S implies ABC. So RDPS, and I will say S implies ABC. Now, since we have the three, you can say three symbols here, X1, X2, X3. So for each and we have to check each and every symbol. Na? So I will say here I is equal to 1, I is equal to 2, I is equal to 3. Now I is equal to 1. This is what? A, na? So this is non-terminal. So since it is a non-terminal, so I will do a recursive call RDPA. Now RDPA, what it will do? A goes to, there is only one production AB. So I will write it here. A goes to AB. Now again, we have two symbols na, X1 and X2. I am writing here also. This is X1, X2, X3. Okay, so we have three symbols here. So here two symbols X1, X2. So I is equal to 1 and I is equal to 2. I is equal to 1. I is equal to 1 means what? This is A. So see the input look ahead pointer is pointing to the first symbol na. So A and A both are matching na. See here carefully. Okay, if it is a variable, then we will call a recursive call. Otherwise, we will say xi is equal to look at symbol or not. If it is look at symbol, and look at pointer will increment. So A and A are matching. Okay, so I will say look at pointer will point one symbol to the right. That means it will increment. Now for I is equal to 2, I is equal to 2, B. So B and B also matched. B and B also matched. Look at pointer will point one symbol to the right. Now see the see here carefully. Now since for loop, now this for loop is done, completely done. Okay, so I will say what? That this you can say function call is over. Whenever loop is over, obviously function call is over. Okay, so loop is over means this function call is over. Yes. So x1 for x1, that means S goes to ABC na. So for this A, we have done this recursive call. This is over. So I is equal to 1 part is over. Now we will concentrate on I is equal to 2. Let me use a different color. Okay, I is equal to 2. We will concentrate. So B na, B is what? Non-terminal. Non-terminal. So what I will do? RDP of B. Now RDP of B goes to what? CD. So B goes to CD. This is x1, this is x2. So I is equal to 1 and I is equal to 2. I is equal to 1, C. Okay, C and C both are matching. So look ahead pointer will point one symbol to the right. I is equal to 2. That is what? D. This is D na. So D and D also get matched. So look ahead pointer will point one symbol to the right. Now since the loop is over, okay, because see we have two symbols, and for I is equal to 1, I is equal to 2 we have done. So loop is over. See here carefully. Loop is over. Loop is over means what? Function call is over. Function call is over. So this will be popped off. Okay, so this is over. So obviously this is gone. So I is equal to 2 now over. Now we will concentrate on I is equal to 3. I is equal to 3. Okay, so what we should do for I is equal to 3? So RDP C. This is again non-terminal, so we will do a recursive call RDP capital C. Okay. Yeah, so RDP capital C. So what we will say, capital C goes to, okay, we can start from any production. Let me start from here, EF. Capital C goes to EF. I will say EF. So X, this is X1, this is X2. So I is equal to 1, this is E, and here we have I. Matching is not done. Matching is not done, then see here carefully. If Xi is equal to LS, look at symbol, then we will do look at pointer plus plus, else parsing error or backtrack. So we have two options. So backtracking option is still present. We will backtrack. If we have done all the backtracking, then we will say parsing error. Okay. So we will try to backtrack. Backtrack means what? We will pop this. Okay. We will pop this and we will again call RDPC. Okay. We will again call RDPC. And this time we will apply next production. Next production was what? GH. This is GH now. So I will apply C goes to GH. This is X1, this is X2. So I is equal to 1G. And here we are having I. So G and I are not matching. See here carefully. This is I and this is G. Both not matching. Not matching. So what? Again, see the previous slide. What we have shown, parsing error, or we will do backtracking. So parsing error we cannot give because backtracking option is still present. So we will backtrack. We will backtrack means what? This is popped and again backtracking is done. So now let me use a different color. I will say RDP of C and C goes to, okay, what? IJ. Yes, so I will apply C goes to IJ. This is X1, this is X2. I is equal to 1. So I, and here also see here. Here also we are having I and I both are matching. Both are matching. So look ahead pointer will point next to the next symbol, that is J. Now X2 is what? I is equal to 2 now. For then when I is equal to 2, we will have a J. So J and J both matched. So that's it. Everything is done. So what I will say, loop over. Okay. See, we have two symbols now. We have two symbols I and J. So for I is equal to 1, for I is equal to 2, two symbols we have done. So loop is over. So this is over. Now since this is over, so this was called by what? RDPS. So obviously now I will say anything is left. No, nothing is left because I is equal to 1, I is equal to 2, I is equal to 3. We have done all for all the three symbols. We have separately called the functions. Okay, so everything is over. So what I will say parsing success because nothing, no error is shown. So I will say success. Okay. So actually I have not written the program very precisely. So please do not say, sir, where it is parsing success and so on. I have just given you a small idea about how exactly RDP is working. We are not concerned with writing programs and so on. We are just concerned with the working. So I have just roughly explained the working. So answer will be yes. So it is parsing success. Okay. Why it is parsing success? Because everything is over properly. So it is parsing success. Okay. So let me give you small time to write all these things. Okay, or let me shorten it. Yeah, now I think everything is on one slide. Please try to note it down and I will jump to the next slide now. Okay, so okay, yeah, and here only I will show you something. Okay, so in GATE exam or in any competitive exam, they can ask recursive descent parser is using which data structure? Which data structure it is using? See, obviously here we have used what? Recursion. This is what recursion only, na? We see in RDP function we are again calling RDP and so on. So this is recursion only. So recursion means what? Recursion means data structure used will be what? Stack. Please try to remember. Recursive descent parser uses stack data structure. This can be asked. Okay. And main disadvantage is what? we are doing backtracking again and again. Here we have done backtracking. Here. So here we have got the success now. So 2 times we have done backtracking. So backtracking will waste lot of time. So that is a very big disadvantage of this parser. Okay. So lot of backtracking is done. Lot of backtracking is done. Hence, this parser is slow. This parser is slow. Slow in the sense because backtracking is done, na? Backtracking is done again and again, so it will take a lot of time, na? What function is called and so on. Okay, actually, I'm not going into basics of recursion and so on, and I hope that you all have done recursion in your data structures and algorithm part. Okay, so you already know that whenever function is called, activation record is pushed onto the stack and so on. So activation record will be pushed and unnecessary it will be pushed and unnecessary it will be popped because it is not used and so on. So it will take lot of time. So indirectly lot of time is wasted. Okay. Yeah. So hence this parser is very slow. Please try to follow it. Pause the video, note it down, and I will jump to the next slide now. Okay. Yes. So I will show you now example 2. Okay, one example we have done. Next example is S goes to AS or B. Okay, and my input string is triple A B. Now try to make recursive descent parser for it. So look ahead pointer will point to the first symbol. So RDPS. We will directly start from recursive descent parser RDPS. Okay, and I will say what S goes to AS. So this is x1, this is x2, I is equal to 1, I is equal to 2, I is equal to 1 is A and A are matched. So look ahead pointer will point to the next symbol, I is equal to 2, it is what? S. Now since it is S, that means non-terminal. So we will do a recursive call, we will do RDP of S, RDP of S. So S goes to AS, okay. So we can apply any production. We can start from any production, whatever production we want. S goes to AS or S goes to B. So we can start with any production, and I'm starting with AS. Okay. So this is x1, this is x2. I is equal to 1, I is equal to 2, I is equal to 1 is A. So A and A are matched. Look ahead pointer will point to the next symbol. Now I is equal to 2. It is a non-terminal. So non-terminal. So we have to do what? Recursive call. So we will do a recursive call RDP of S. RDP of S. We will do a recursive call. Now we will say what S goes to AS. Again S. So we can apply any production, whatever we want. AS we have applied. So this is x1, this is x2, I is equal to 1. Sorry, I is equal to 1, I is equal to 2, I is equal to 1 is A and A are matched. Look at pointer is pointing to the next symbol. I is equal to 2, this is S. This is S, so we have to do RDP of S again. Okay, so I will do RDP of S again. So again we will write S goes to AS. So I is equal to 1. Here we have A. Okay, but here we have B. See here carefully. See here carefully. We have B and here we have A. So mismatch. Mismatch means what? Backtrack. So we will pop off and we will again do recursive call RDP of S. And now we will apply the next production. This is backtracking. Okay. So this is backtracking process. This is backtracking. Yeah. So now what we will say RDP of S. So next production is what? See, we have applied this production. We have not got the success. We will apply this production. S goes to B. So I will apply S goes to B. So X1 only one symbol here. So I is equal to 1. Here B and B are matched. So that's it. Loop is over. Here loop is over. See the slide now. This loop is over. For loop is over. So for loop is over means what? We will pop off. This will be popped off now because this is popped off. So this was called where? This was called here. So again, loop is over. This will be popped off. Now this function was called where? In this function it was called. So this is also over. This is over now. So loop is over. So this is over. This is over. So parsing success. Yeah. So I hope I have made the point clear. This was example number 2. So you have got, I think, more clarity. Let me show you one more example. Okay. Yes, please try to follow it. Please pause the video, note it down, and I will jump to the next slide now. Okay. Yeah, I am jumping now. Now we will study example number 3. See, in the previous slide we say S goes to ASB. Now I will say S goes to SAB. Here we have right recursion. Now I will show you left recursion. SA or B. Okay, and the input string is B triple A. Look ahead is pointing to the first symbol. Now I will directly start RDP of S. RDP of S. So first production is what? S goes to SA. This is x1, this is x2. I is equal to 1, I is equal to 2, I is equal to 1. We will say S. Okay, because I is equal to 1. See here careful, this is S now. So we will call again RDP of S. Okay, RDP of S. Okay, let me write properly now. I is equal to 1, I will say RDP of S. Now again, we have to apply production. S goes to SA. This is our first production. So again, I will say x1, x2. I is equal to 1 and I is equal to 2. I is equal to 1. Again, this is what? S now. See here, this is S. So we will call RDP of S. Now when I call RDP of S, again, I will say S goes to SA. So x1, x2, I is equal to 1, I is equal to 2. For I is equal to 1, I will again say what? This is S now. So RDP of S and so on. So it will go in infinite loop. Okay. So we won't be able to get the answer, or you can say recursive distant parser will go into infinite loop. Okay. And I have already told you top-down parser. Okay. See the slide. Top-down parser of two types, top-down parser with backtracking, without backtracking. And I have already told you none of the top-down parser can parse left recursive grammar. Okay. In LL1 parser, I have told you left recursion is a problem. And in recursive distant parser also, I'm saying left recursion is a problem. So typically with top-down parser, left recursion is always a problem. Okay. So left recursion must be removed if we want to parse any grammar with top-down parser. Okay. Yes. So now let's come back to our slide. Yeah, we will go to infinite loop. Okay. So see, now there is a very small difference. Okay. So theoretically, this is true. Theoretically, I can say it will go into infinite loop. But practically, what exactly is happening? If I say practically, what is happening? See, whenever a function is called, you have studied in data structures and algorithm. Whenever a function is called, its activation record is pushed onto the stack. So first time RDPS will be pushed onto the stack because the function call was this. Now again, RDPS has called RDPS. So again, activation record will be pushed onto the stack. Whenever function is called, its activation record is pushed onto the stack. You already know from data structure algorithm. So again, RDPS and so on. So now see carefully, this stack has limited memory. It is not unlimited. Okay, limited memory stack. Because in computer memory is limited. Limited memory stack. Or you can say runtime stack. This is runtime stack. So this is has limited memory because computer overall is having limited memory. It is not having infinite memory. Okay, so after say let us suppose roughly after say 1 lakh times, roughly I'm saying 1 lakh activation records have been created, and after that memory is exhausted. So when memory is exhausted, we will get an error message stack overflow. Okay. So let me write properly. We will get error message stack overflow. So if anybody say that it will go into infinite loop, you will say theoretically yes, we will go. It will go to infinite loop, but practically that means when we run it on a computer, then it will never go into infinite loop. We will get an error message that is stack overflow after few minutes or after few seconds, depending upon the computer speed and so on. Okay, I'm not going into that much detail, but I'm just saying that stack overflow error message will come after some time. That's roughly I can say after some time stack overflow error message will be shown. Why it will be shown? Because obviously stack has limited memory. So see, whenever RDPS is called, activation record will be pushed onto the stack. So we can call it limited number of times only. We cannot call it infinite times. Infinite time means what? Stack must have infinite memory, but stack we already know it does not have infinite memory. Okay, so hence it will create problem. Okay, so I hope I have made the point clear to all of you. Please try to follow it. Okay, please pause the video and try to note it down, and I will jump to the next slide now. I hope you all have noted down. Okay, so I will jump to the next slide now. So this was example number 3. Now I will show you the last example, which is also very important, and you will got to know some more points about this parser, which can be directly asked in GATE exam or in any other competitive exam. So let me say we have S goes to AB, BC, CD. A goes to A or AB, B goes to CD, C goes to EF, D goes to GH. Okay, and let us suppose the string is ABCD. This is our input string. We want to check whether this string is generated by this grammar or not. Clearly, we can say this string can be generated because A can go to AB and B can go to CD, obviously. Okay, so S goes to S goes to AB, A goes to AB, and B goes to CD. So this string can be generated. Now the question is how this your recursive descent parser will work here. So let me give you a small idea. Okay, so let me short it. Yeah. So let me start from here. Yeah. So I will say RDP of S. So we have to apply production. So I will say S goes to AB. First production is this. X1, X2, I is equal to 1, I is equal to 2, I is equal to 1. This is A na. So I will write RDP of A. Now A goes to A. So this is X1. This is X1 means what? I is equal to 1. This is what? A. Look ahead, pointer is pointing to A. A and A are matched. We have got this success. So this is, you can say, popped off. And I will say I is equal to 2 now. Okay, so look at pointer will point to the next symbol because matching is done. Now I will say I is equal to 2, that is what? B. So I will write RDP of B. RDP of B. So B is saying what? CD. So B goes to CD. Okay, B is going to CD. So this is what? X1, this is what? X2. I is equal to 1, I is equal to 2. C. Here we have C and here we have B. Matching is not done. So I will say what? Backtrack. Now, when I say backtrack, now B is not having any option. Now see carefully. B is not having any other option. If it was having, say, EF or GH and so on, it can having some other, if it was having another option, then I will do that also. Let me say this is X. Okay, roughly I'm writing. So now I will say we will do backtrack. Okay, so please try to follow it. Please do not say this is backtrack. This was success. This was your success. and this is backtrack. We have done backtracking. So again, I will write RDP of B, and I will say B implies X. This is X1. So I is equal to 1. Okay, so X, and here we have B. Obviously, these are not matching. So I will do backtrack. Now, after backtracking, I will say no other option is left here. So try to follow, please try to follow here, since no other option is left here. So B will say problem is not with me, problem is with my parent, that is what S. So now it will backtrack. Okay, this is very, very important point. So now again we will do backtrack, and S goes to AB is we will say that it is not working, and we will start with S goes to BC. Are you getting it? So when no other option is left with B, then we will do backtrack, and B will say problem is not with me, problem might be with my parent. Okay, so parent is what? S. So we will do backtrack, and we will say, okay, S goes to AB. I think we have applied this production wrongly. So we will say, we will try next production. Okay, so what we will say? We will say here again RDP of S. So S implies BC. Okay, or rather we should not write again because we have done backtracking. Na? So let me expand it here. Okay. Because RDP writing again means what? We are doing again a function call. We are not doing again a function call. We are just trying the next production. So RDPS, and I will apply the next production, that is S goes to BC. Okay, now X1, X2. So I is equal to 1, I is equal to 2, I is equal to 1 is what? B. So we will apply what? RDP of B. Obviously, we will say what? B goes to CD, and this is X1, this is X2, I is equal to 1C, C, and here we have B. Okay, these are not matching, and so on. I think you can guess these two things will be copy pasted here. So backtracking will be done. Okay, and after backtracking, no other option will be left. Okay, let me write it again. RDP of B. Okay, rather I should not write it again because this is backtracking. Na? So we can extend it, and I will say B goes to X. Okay, B goes to X. So again X1. So I is equal to 1, X, X, and here we have B not matching. So I will say, okay, so please, I think problem, B will say problem is not with me, problem is with my parent, that is S. So we will do again backtracking. Okay, we will do again backtracking, and we will apply S goes to CD. We will apply S goes to CD. This is X1, this is X2. So I is equal to 1. Okay, I is equal to 1. So RDP of C, capital C, no? Because because capital C is a non-terminal, so we will do RDP of C, recursive call. Okay, so C is going where? EF. So C is going to EF. EF. X1, X2, I is equal to 1. This is E. We have got E, but in the string we are stuck at B. Okay. We are stuck at B. Yes, so what can be done? So I will say C, and for capital C, see here carefully, there is no other option. Okay, since there is no other option, so C will say what? Problem is not with me, it might be with my parent, that is S. So S will try to again backtrack, and no other option is left with S. So it will say no other option now. So we cannot do backtracking. Now it will say parsing error. From the program, you can see parsing error or backtrack. Okay, so backtracking cannot be done. So final answer will be parsing error. So are you getting it? So you have got more clarity here. Okay, and here also, actually it hardly matters. I am just representing. So you may argue that, sir, we should say this is also backtracking, so we can extend it. and we should not say here RDP of T. Yeah, you can say like this also, but it hardly matters to me. Actually, this is just my representation. You can have your own representation, how you represent the things and so on. Okay, so please do not get confused here. So here we have done backtracking, and then we are again calling B. So actually, we are not again calling B. We are just you can say uh, using the other production. That's it. Okay. Yeah. So actually, it hardly matters. So please do not concentrate on all these points. Okay. So just leave them. So it's your own way. It's your own wish how you can do. Okay. So I have just extended it like this RDPS. So S goes to AB, then S goes to BC. For S goes to BC, I can write like this also RDP of S. But it may give you a wrong message that we have to call RDP of S again. No, we are not calling it. We are just doing backtracking. Okay, that's why I have extended this line. I have extended this line, and I am not saying that RDP of S is called again and so on. But still, since we are just doing a question, so we can do like this also. RDP of S like this also you can do, because GATE is an objective paper. It is not a subjective paper. So we will not concentrate on such basic or very minute points. But the question can be asked is, in backtracking, function is called again? No, function is not called again. Okay, so we are just you can say using another option. That's it. Okay. Yes. So please try to follow it. Okay. Yes. So I hope you all have noted down. So we have got a very important point here. We have already told you that ABCD belongs to this grammar, or you can say this grammar can generate string ABCD, but parser is saying no, it cannot be generated. So the basic problem here was this: S goes to A and AB. That is common prefixes problem. Now, since A has got the success, now that was the major problem. We cannot say to its sibling that you are not correct. We cannot say to it because A is already over. A has got the success. So we cannot complain A. We can complain only to its parent because its parent is not yet completed. Okay. So see, you can complain someone who is present. If someone is absent, then you cannot complain. So obviously we cannot complain A because A is now nowhere in the memory because A has already got the success. So we cannot complain A. So the only option with B is it can complain its parent, that is S. So B is saying that problem is not with me because I have applied all the options. Problem is with you. That means parent. So he is complaining the parent. So parent will backtrack and so on. So, but after backtracking of the parent, we have not got the answer correct. Okay, so I hope I have made the point clear to all of you. Yeah, and some of you may argue that, sir, what if we have in place of this small a, at starting itself, we have applied this AB? Yes, you may get success also. In that case, obviously, you will get the success. So it is random thing. Okay, so from wherever production we want, we can start. So the best answer will be whenever we have a common prefixes problem, then recursive descent parser may not give correct answer. That is the best way to say. Okay, it may not give correct answers. Okay, yes, please try to follow it. Yes, pause the video and note it down, and I will jump to the next slide now. Done. Okay, now I will give you some summary, or you can say final note. Okay, so the note is note is the first basic point is in RDP. In RDP, we will write recursive programs. We will write RP, that means recursive program, for every variable or non-terminal. Second, in RDP, lot of time is wasted due to backtracking. Lot of time is wasted because of backtracking. third point. In RDP, okay, if grammar is left recursive, if grammar is left recursive, then RDP cannot parse it because it will go to infinite loop, and in bracket you should write theoretically. Theoretically it will go to infinite loop, but practically it will not go. Practically we will got an error message that is stack overflow. Okay, yeah. So, and the last important point is, okay, so this point has been cleared in example number 3. Okay, and in the example number 4 we have studied about common prefixes problem. So if common prefixes problem is present, then RDP may not give correct answer, or it may give parsing error. Okay, if CPP, common prefixes problem, is present in grammar, then RDP may not give correct result. May not give correct result. Okay. So these are the 4 basic points which you have to remember about RDP. One more important point is left, and this has been asked in many competitive exam. Okay, and let me write, that is the 5th point. Okay, so can you tell me, it is using RDP is using LMD or RMD? LMD or RMD? What it is using? Can you tell me? Okay, so see the previous slides, you will get more clarity. Okay. Let me show you the slide. Okay, so yeah, see here, we have applied the loop, and the loop was for I is equal to 1 to k. Okay, so 1 to k means what? We are expanding this x1, then x2, then x3, then x4, and so on. So obviously we are using what? LMD. Okay, so LMD is applied. Please try to follow it. In RDP, LMD is applied. So in RDP, in recursive distant parser, LMD is used, or LMD is applied. Why LMD is applied? Because if I say I have, let me say in more, or you can say more easy way. So RDPS, we have called this function. Okay, and S goes to AB, and we are saying x1, x2. So A. So first we have called RDP of A. Okay, we have not called RDP of B. So we have called RDP of A directly. It means we are expanding A, and then we are expanding B. So this is what? LMD only. Okay, so I hope I have made the point clear to all of you. Please try to follow it. Okay, please note down all these things. These 5 points are very, very important. Pause the video, note it down. Okay, so that's it for today. So we have done our top-down parsers. Okay, so let me show you the summary. Please note it down carefully. Okay, I'm jumping to next slide. Yes, so I have already told you many times that parsers are of 2 types: top-down parser and bottom-up parser. Top-down parser we have completed. That means recursive distant parser and non-recursive distant parser. Non-recursive distant parser was LL1, and recursive distant parser we have studied in today's class. So top-down parsers are over. Now we will start bottom-up parser, and in bottom-up parser we have to study 2 parsers. One is LR parsers, and another is operator precedence parser. So in the next class we are going to start operator precedence parser, and hopefully we will complete it. And from the next to next lecture we will start LR parsers. Okay, LR parsers are very important. Many questions have been asked in GATE exam from this topic. Yeah. Okay, thank you so much. Bye bye.